Hi guys, welcome to another session. This session we are going to see about how to build a web application using Anvil, Colab and KNN. Anvil is a framework which uses Python language, and Google Colab and K nearest neighbor algorithm is a popular classification algorithm in machine learning. Colab we are using for Python coding. These are all the prerequisites. Basic knowledge on Python and machine learning concepts is required. So machine learning concepts in specific, we need classification algorithm KNN. These are all the steps. Design your application in Anvil is the first step. We are using Anvil framework for design section as well as client side code section. The second step is coding is Anvil. The third step is connect your application to the Google Colab and publish the application is the fourth step. And finally we are going to deploy our application in mobile. So this is my Anvil framework account. As I said, we are going to create an application in this platform. Click a new app, that means we are going to create a new app here. Click blank app, choose material design, so this is the design section. So initially we need to have a column panel, so we have two sections, toolbox and properties window. Toolbox contains of all the tools. So we are placing a column panel here. It acts as a container in which we are going to place the label and text boxes. Since our dataset contains several fields, we have several labels and text boxes. Yes, we need a drop down list for storing island, and we need two radio button as well, and we are going to name it. The first feature or first column is column length, so we are going to have a text here as column underscore length. I make it as bold. I made it as center alignment. In the role I choose input prompt. Likewise I do the rest of the labels as well. The second field is flipper length, made it as center alignment. The third field is body mass. I made it as bold, center alignment. And the fourth field is column depth. The fifth field is island. And the sixth field is 6. In the text box 1, I name the control as txt underscore cl. Cl stands for column length. Likewise, I do the rest of the text boxes. Fl stands for flipper length. Then txt underscore bm. Bm stands for body mass. And txt underscore cd. Cd for column depth. And drop down list, in short I give DDL1. And for the first radio button I give RD male, since it's for male. And the second radio button RD FEM. I put a button. I name it as classify and I place a label for output displaying. I name it as LBL underscore RES. That means it's for result. So initially it's default by visible. I make it as invisible now. I'm going to rename my application as Penguin app. I change my application's logo. I have it in local. This is my application logo. I move to the form section again. I wish to rename my buttons text as classify and the radio group is sex. Also radio button 2 as sex. The text of radio button 1 is changed to male. Radio button 2 text is changed to female. I make some proper arrangement here. The value should be here 1 for female and male for 0. Yes, I am going to give some items for drop down list. Bisco, Dream and Torgersen. Torgersen is the island's name. So I am approximately I am done with my design section. I made proper alignment. In text box I need to have some placeholders. So in the placeholder section I make some necessary changes as well as in the data type. You make sure that the text boxes are in number data type. Yeah, I almost finished my design section and I click uplink and enable the server uplink. This is the connectivity uplink code. Make a copy and store it somewhere. It will be immediately used for the connection with the Google Colab. So that's all from here and I click on the button and I move to the coding section now. I have a code here and I place it over here. So here we have a validation for all the fields. So whether empty field will not be advisable for passing the input to the model. So we check the validation here whether all the fields have necessary inputs or not. Here once the flag is true, we are going to check the radio options are properly checked or not, and this is for island fields selection. So this is the code. RES is for storing result. Anvil.server.call. Predict_PEN is the functionality we have in our Google Colab. And once it is successful, the label will be enabled visible and output will be displayed. Once it is false, enter necessary details will be displayed. We move to some theme section. If you wish, you can change the theme of your application. You can choose blue colors. So I move to form 1. I'm going to check whether the design is okay. Yes, it is properly visible. I'm stopping it now. So this is our Google Colab section. So this particular notebook gives you the detailed information regarding the Google Colab. So initially we have some steps to be followed and the libraries or packages required. Run the appropriate cell. The information prior to the cell gives you a clear idea about the application. So you need to pass uplink key here. The uplink key is, as I said, you get it from the application, paste it over here, give enter. The cell is executed now, and you install the Anvil underscore uplink library here. The dependencies are loaded now, and import the anvil.server, and now you can connect your notebook with your application via uplink key. This particular feature enables or gives us the opinion about this particular application is connected or not. This particular data set, we need to load the data set in our Google Drive now. So for this particular cell is used. Once it is executed, we are able to load our data set in Google Drive. It is executing now. Expand the folder option. You can see the content/drive option. Yes, you can expand the drive option, under which you can expand my drive and Colab notebooks. We can have a folder demo. So this is the area where I can store all my stuffs. So under demo, right click, click upload. You can choose your data set which is available locally. Yes, choose your data set. Yes, it is successfully uploaded into your drive. Copy the path. You have to read the contents of the data set. You have to copy the path and paste it over here. Execute it. You can have a preview. Since penguins.head displays only the top 5 rows, you can preview the data set over here. Yes. You can have multiple commands like penguins.describe, penguins.info. These are all the commands gives you the exploration of a particular data set. The info gives you the column and data type details as well. So now we have the counts of particular data cells field basis. Say for example, here we have Adelaide species count as 151 and Chinstaff's count as 68 and Gentoo is 123. I wish to remind you, these are the species of penguin. We need to visualize the data. Yes, once we are getting the input read operation from the data set, we need to have a visualized view. Yes, this is a bar chart. Previously I had pie chart type. So we have 3 kinds of penguin species. So here the command is counts of sex. Based on the sex feature, we are categorizing the penguins count. 168 and 165 count is here in the dataset. The next thing is mean value calculation. By grouping the species count, mean is calculated here. By grouping the island count, the mean is calculated over here. And based on the sex, mean is calculated here. And finally, we are into the important section, which is train and validate dataset section. So here the features X0 have numeric fields values, means culmen length and flipper length and body mass and culmen depth, and the string features species is the predicted value which will be stored in Y, and island and sex features are stored in Z. We need to encode the labels here because some labels are numeric, some labels are having string values. So having fit transform field, we are applying. I need to run the previous cell first. So run the previous cell and execute it now the current cell. Yes, it is executing successfully, and we are concatenating X0 and Z2. Finally, we are getting the X, where X have zeros and ones are all numeric values. You can see island and sex values are turned with 0, 1 and 2 values. You can see here, right? Yes. Now we are moving this particular information as data frame, and we are downloading it as CSV file. Yes, I am executing the command data frame of X, where X contains updated CSV file. Yes, I am storing the updated file in the appropriate path. I need to change the path here. Yes, content/drive/my drive/collab notebooks/demo is the appropriate path here, and I am naming the file as penguin_size updated. So whether we are having it or not, yes, we have the updated file in the appropriate folder as well. Initially we have penguin_size.csv and the updated file penguin_size_updated.csv as well. This updated files, I wish to remind you that this updated file can have numeric values alone after label encoding process. Yes. So we are going to split the dataset into two parts, train set and test set. 75% and 25% is the ratio I have taken here. 80-20 is the advisable one. I am executing the files. Now I am getting out of 400 something dataset values. I have 75 for training and 25 for testing. As so, label encoding species is done here. Here we get Y1 and Y2 after fitting the transforms using the appropriate functionalities, and we are using standard scalar for standard deviation calculation, and finally we are previewing some trained and test sets values here. This is the main part. This is the model. We are using Neighbour classifier. Yes, it is imported from sklearn.neighbors, and as well as we have some F1 score, accuracy score and all. So these are the metrics values. We are deriving it from sklearn package. So Neighbour classifier is the functionality we are using here. So ravel is the function used for flattening the array. So we are getting precision and recall and F1 score are displayed over there, and we are printing predictions which is filled with 0 and 1 kind of values, which are all derived from the previous operation. So this is the output. We are going to predict which kind of species as Adelaide or Chinstrap or Gento. Okay, so to obtain this, we need to perform some computation over here. So we need to calculate the mean value of each features in the data set. So the first row means that download the updated file in your local system. You can explore the updated CSV file. You can have a mean and standard deviation value from there, and calculated mean and standard deviation values of each feature or each column can be placed over here. So the computation goes like this. So once we calculate the mean values and the standard deviation values, we are expecting our output in the STX new list. We are performing CT equal to V minus mean divided by standard gives us, in each iterations it gives us the difference value that will be tested with new data type. So for example, we are going to check, we are going to confirm with that with a new entry, that is 50.9, 196, 3550 and 19.1 and 1. Yes. So this is the definition part. This is the callable function from the application to the Google Colab. As I said, we are having mean and as well as standard deviation values. This is the trained model. We are executing it. Finally, the prediction done by means of having KNC classifier. And finally, we are testing with the new entry. As I said, 50.9, 196, 3550, 19.1 and 1, 0, where 1 denotes the island's value, 0 denotes male or female. Yes, 0 denotes male. Yes, good. So I am going to execute it. Execute the console now. Yeah, we have got the exact output. Chinstrap is the species for this particular feature set. 50.9 Kalman length, 196 flipper length, 3550 body mass, and 19.1 is Kalman depth. So we are freezing our requirements.txt file, and finally we are going to publish our application. Yes, we can customize our code as well. ck-penguin-app. So this is my web app link name. So I am clicking on it. Yeah, it is running fine. Yes, so we are going to test it now. 50.9 is the Kalman length, 196 and 3550 and 19.1, and we are choosing the island as Bisco and male. Click classify. Yes, Chinstrap is retrieved over here. So we are getting the exact output. You can check it with the dataset as well. You can run based on different data inputs. test again with another input. 49,212. Body mass is 4,300. I'm getting the input from the dataset. 19.6. I check the new entry. Male and a dream is the island. Yes, it retrieves Chinstar. It's time to check it with the mobile. So I'm going to use the same link here, ck-penguin.anvil.app. It's asked me to install the app. Oh, it's great. We are going to have mobile here. Yes, I'm installing my app in my mobile. I wish to open it. So I am going to give the new entry. I wish to give 50.9 once again, 196 for flipper length, and 3550 for body mass, and 19.1 as Kalman depth. And I choose Bisco Island male. Yeah, the species is Chinstar. I am getting the right answer.